In this video, you will learn how to subtract integers. First, let's start out the same way we did with adding integers, and let's take a look at a pattern. See if we can identify what is happening when we're subtracting these integers. Negative 5 minus 1 is negative 6, negative 5 minus 2 is negative 7, and negative 5 minus 3 is negative 8. What would you get for negative 5 minus 4, and negative 5 minus 5, and negative 5 minus 6? If you said negative 9, negative 10, and negative 11, you are correct. The pattern going down is easy to follow, but let's look at an actual individual problem on its own and see if we can make sense of where we get our answer from. Negative 5 minus 4, if you think of our number line, negative 5 would be 5 spaces to the left, and then when you subtract 4, you're also going 4 spaces to the left. So in this problem, we're adding 5 plus 4 to get 9, and since we're going to the negative side of the number line, our answer is negative 9. Let's show this on a number line. Starting at 0, 5 spaces to the left is negative 5, and then taking away 6 goes to the left. That is all the way down to negative 11 on our number line. Oops. Now let's look at a different type of problem. In this case, we're taking 5 and we're subtracting a negative 1. So 5 minus a negative 1 actually equals 6. 5 minus a negative 2 is 7, and 5 minus a negative 3 is 8. Continuing the pattern, we would have 9, 10, and 11. And let's take a look again. How is that possible? Well, when you are taking away a negative, if you notice, we actually end up adding the two numbers together to get positive 9. This is an example of double negatives. You might be familiar with the double negative in English or when you're writing as well. Double negatives always cancel out to make a positive. So for example, these are just a few sentences that you might have heard that have double negatives. If you say, I didn't do nothing, those are two negatives, which actually means you did do something. If you say, I miss not seeing him every day, miss and not are the two double negatives that cancel out. And if you say, I don't have no money left, those are your two negatives that cancel out to make a positive, to mean you actually do have money left. Same idea applies to math. When you take away something that is negative, you're actually adding that on. So how that looks on the number line is that we are starting at 0, we're going to positive 5. And then when you take away a negative 6, you're actually adding 6, which continues to the right and gives us a positive 11. So you have to pay attention to that double negative, and you have to know that that cancels out. Taking away a negative is actually adding. Think of that as if you owe somebody money. If you take away your debt, then you are not losing any money. Okay, so what we are going to do when we are subtracting integers, to make this a little bit less complicated, we are going to actually change our subtraction problems into addition so that we can just use the rules that we already learned for addition. So you're going to change subtraction to adding the opposite of the second number. Okay, this you can kind of use the idea of keep, change, flip if you remember that from when you learn how to divide fractions. Those same three words can help you change a subtraction problem into an addition problem. So for example, 5 minus 6 is the same problem as 5 plus a negative 6. So you're going to keep the first, change a subtraction to addition, and then flip the positive 6 to a negative. This allows us to reuse the rules we learned yesterday and get our answer of negative 1, since these are different signs and we subtract when we are working with different signs. The second example, 5 minus a negative 6, if you do keep the first, change subtraction to addition, and flip the -6 to a +6, you end up just getting 5 plus a +6, which is 11. This can be a little bit tricky at first, so let's do a few practice problems to get in the hang of using that idea of keep, change, flip to change subtraction into adding the opposite of whatever that second number is. So opposite means if it's positive, it becomes negative, and if it was negative, it now becomes positive. So let's try this first example. 11 minus a -4, keep the first, change a subtraction to addition, and flip -4 to the opposite. Now we have 11 plus a +4, which is just 15. 8 minus 21, if we keep the first, change a subtraction to addition, and flip the +21 to a -21, now we can apply the rules that we learned yesterday with 8 plus a -21. When we have two different signs, positive and negative, we subtract the two. So we're going to do 21 minus 8, which is 13. And since we're taking away 21 from only a +8, we're going to end up at -13. -15 minus 12, we can change to keep the first, change subtraction to addition, and flip the +12 to a -12. Our new problem is -15 plus -12. Using our rules from yesterday, -15 plus -12, since they are the same sign, both of the numbers are negative, we're going to add them and keep our sign. So we get an answer of -27. And lastly, -9 minus a -5 becomes -9, keep, change subtraction to addition, and flip a -5 to a +5. So our new problem is -9 plus 5, which applies our rule for when the two numbers have different signs, we will subtract. So 9 minus 5 is 4, and since we have more negatives than positives, that's a -4. Before you try these problems, I just want to point out why we can do this and why we have to change subtraction to adding the opposite. Why can't we just change subtraction to addition? Let me just give you one quick simple example. So let's say we have the problem 10 minus 2. Obviously we know that is 8. But if we apply the idea of keep, change, flip, let me just show you why we can't just change it to 10 plus 2. Obviously, that is 12, which is not the same problem as 10 minus 2. So if we use the idea of keep, change, flip to change our subtraction problem into an addition problem, it would become 10 plus a -2, which is also 8. So these two problems are the same, which is why we can't just change subtraction to addition, but we also have to change the +2 to a -2. So the idea is that we are going to add the opposite of that second number. So you can't just change subtraction to addition. 21 minus 27 is a completely different problem than 21 plus 27. So we need to change it to 21 plus a -27. Go ahead and pause the video, give these a try, and then unpause to check your answers. Again, these problems will change to adding the opposite. So if you didn't get those right, I'm going to just write down here what you should have changed the problem to so that you can see if you forgot to change something or where you maybe made your mistake. Oops. Once you change the problem, then you still need to apply the rules from adding integers. So in this case, you would have subtracted the two problems. In this problem, you should have added the two numbers. In the third, you should have subtracted. In this fourth, you should have added. And in the last one, you should subtract. Recall the rules where we said that the same signs equal addition and different signs equal subtraction.